Hey guys, Paradoxio here. Welcome back to a brand new computer science video, everyone. Today we are going to be talking about conversions between binary words and decimal numbers. In this video, we are going to be learning how we can convert a binary word to a decimal number, which is the numbers that we as humans read and interpret. We're also going to learn how to do the exact opposite, which is converting those decimal numbers that we can read back into binary. Now, if you haven't watched my last video where I explain binary and sort of introduce you guys to the topic, then I highly recommend that you watch that video first. It's only about 10 minutes, and it'll help you prepare for this video. Or if you already feel like you know enough about binary to dive into conversions, then feel free to stick around. Either way, sit back, relax, and enjoy the video. And don't forget to take any notes if you're watching this for a college level class. Alright. Conversions between binary and decimal numbers. So how do exactly we convert a binary word to a number, which is also known as base 2 to base 10 conversion? Well, there are 4 simple steps involved. We need to write the indices for each bit below the binary word. Then we need to take the number 2, make it our base, and bring that base 2 to the power of each index position. And then for step 3, we need to multiply that exponent, or that 2 to the power of that exponent, multiply it by 1 if the bit is a 1, or multiply by 0 if that bit is a 0. And then we can sum up all of our numbers to get our final answer. We have example 1 here. We need to convert the binary nibble to base 10. And our nibble is 1011. And we want to convert it so that way we can actually know what this number is. So let's get started. Now remember, back in step 1, we need to write the indices for each bit. And first, I'm actually going to write our binary word out. So we have 10, 11. So 1011 is what I really meant to say. Let's go back to step 2. We're going to take 2, which is our base, and bring it to the power of each index. So remember, our indices start from the highest all the way down to 0. And our most significant bit will always have the highest index position. What is our index position for our most significant bit? Well, our index position for the most significant bit will be the number of bits minus 1. So we have 4 bits here. That means our most significant bit will have an index position of 3. Then followed by a 2, a 1, and a 0. Step 2 calls to take the number 2 and bring it to the power of that index position. So 2 to the power of 3. Now, if our bit is a 1, we're going to multiply that by a 1. Alright, and then we're going to add. And then 2 to the power of 2. Multiply that by 0 because our bit here is a 0. And then we're going to repeat this process for all bits. So plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. Now, this is also why it's called base 2, because to convert our base 2 binary numbers to decimal, which are in base 10, we have to bring our base 2 to the power of those index positions. Now, let's go ahead and work this out. So 2 to the power of 3 is going to be 8, so 1 times 8, plus 2 to the power of 2 is 4, so 0 times 4, plus 2 to the power of 1 is 2, so 1 times 2, plus 2 to the power of 0 is going to be 1, and that's the same for any other number. So any number you bring to the power of 0 will be a 1. So 1 times 1. Now, 1 times 8 is, of course, 8. 0 times any number is going to be a 0. So 8 plus 0, plus 1 times 2 is 2. 1 times 1 is 1. So 8 plus 0 plus 2 plus 1. Well, 8 plus 0 is, of course, 8. So 8 plus 2 is 10. 10 plus 1 is 11, meaning our final answer is 11. So, the binary nibble 1011 in base 2 format is equal to 11 in base 10, otherwise known as decimal. Now, if you want, there are some online tools you can use to check your answer. If you have a programmer's calculator, you can also check your answer there as well. But let's go to my desktop real quick and come to rapidtables.com. This is probably my favorite websites for just quickly checking my answers like that. But our binary nibble was 1011. Let's convert it. And our answer is indeed 11. Very nice. So, as you can see, it is quite easy to convert a binary word to a decimal. But let's take things up a notch a bit. Instead of converting a nibble, let's convert something larger, like a byte. And this one you may want to have a calculator by your side. So let's write our binary word. So 1101. Let me fix that. I'm sorry, that's supposed to be a 02. And then 1100. Remember, our index position for our most significant bit is always the amount of bits minus 1. So we have 8 bits for a byte. That means the index position is a 7, sorry. Then followed by a 6, 5, 4, 3, 2, 1, and a 0. So 2 to the power of 7 plus 2 to the power of 6. Now I'm going to ignore multiplying by 1 and 0 because we know what the answer is going to be in that case. Now, since these are zeros, we can skip the 5 and 4. So 2 to the power of 3 plus 2 to the power of 2, and then we can skip those zeros there. So for our case, we're just going to scribble this out. And then we're going to work these 4 separate numbers out together. So 2 to the power of 7. Let's bring out our calculator here. And I'm just going to use Desmos on my phone. Feel free to use whatever you want. 2 to the power of 7 is going to be 128. So 128 plus. And then for 6, I think it is 64. Yep. So 64 plus 2 to the power of 3. That's going to be 8. And then 2 to the power of 2 is going to be 4. Now, once you sum all of these together, our answer is going to be equal to 204. And that is our final answer for this problem. And of course, we can go ahead and check our website here. What was our binary word? 11001100. Let's convert it. And we get 204 as our result. And also, this website has a unique little tool here that we can use, and it just basically gives you the entire formula for figuring out that answer yourself. Perfect. So now we know how to convert a binary word to decimal. But how do we convert a decimal back to a binary word? Well, that is also rather simple, and we'll learn on the next page. All right, and whoops, let me just click out of that. There we go. So now, if you're doing this in a programming language, there are usually certain functions or methods that we can use to convert decimal back to binary and vice versa. But if you're doing this by hand, whether it's on paper or whatever, we're going to be using what's called the division by 2 method. And that goes as follows. So, divide the number by 2. If you do not have a remainder, then that bit is going to be 0. If you do have a remainder, then the bit is going to be 1. Now, take your answer, or otherwise your quotient is what I actually mean, not the bit. So take your quotient found from step 1 and divide that by 2 yet again. And we're going to repeat these steps until our quotient is 0 with or without that remainder. And we're going to do all this in a line from top to bottom. Now, for step 4, we're going to read your bits from bottom to top. The bottom bit, the last one you would have written when your quotient is 0, will be your most significant bit. And please ignore this little note here. I meant to write something there, but it turns out I don't need it. All right, let's try out a problem. Convert 15 base 10 to binary. All right, so let's write down 15 here, and let's divide that by 2. Now, 15 divided by 2 does not divide evenly. We will have 7 with a remainder. So our bit is going to be a 1. Then 7 divided by 2, that doesn't divide evenly, so we're going to have a 1. And our answer, I believe, is a 3 for that, actually. Then 3 divided by 2, that's not going to divide evenly, so we're going to have a 1. And have a 1 there. Or really, it'll be a 1.5, actually. And you'll see why I'm going to write that out. So 1.5 divided by 2 will be a 0 with a remainder of 1. And really, I guess it didn't matter. We could have just left 1 either way, because we're not really interested in the actual quotient at the very end. Now, read this from bottom to top. So 1, 1, 1, 1. Therefore, our binary word for the base 10 value of 15 is 1, 1, 1, 1. And that is our answer. And we can go to our desktop and back to that website again. Reset. Type in 15, and 111 is our binary number. Now, this may be a little bit trickier, and really I didn't even need to write that 1.5, but sometimes I do it just in case, just because it helps me understand that there's a remainder a little bit easier, but that's not necessary. If you just left it at 1, you'll still have a 0 with the remainder, because 1 divided by 2 is 1/2, so it doesn't divide evenly. But 1, 1, 1, 1 is our answer. Now, let's go to the next page and convert 10, which is in base 10, to binary in base 2. So, let's try this out. So 10 divided by 2, that's going to be equal to 5. And that divides evenly, so our remainder will actually be 0. Then 5 divided by 2, and gosh, that looks ugly. All right, just pretend that's a 5. So 5 divided by 2, that's going to be a 2.5. So we'll just write a 2 here. And that's going to have a remainder, so that we'll have a 1. 2 divided by 2 is going to be a 1 with no remainder. And then 1 divided by 2 is going to be a 0 with a remainder. So therefore, our binary word will be 1010. Because we are reading from bottom to top. Now, let's go to our desktop and back to that web page again. And reset. Enter the value of 10. And as you can see, our answer is correct. So that's how we can convert a binary word to decimal, and decimal back to a binary word again. So, with these 4 different examples in mind, I want you to try this problem on your own after the video is over, and leave me your answer in the comments. Convert the binary bytes 10101101 to decimal, and then convert your answer back to binary. Your answer should match the first value that we were given here, which is 10101101. Other than that, in the next video, we will learn to add and subtract binary words. If you have enjoyed this video, please leave a like, comment, and subscribe for more CS content. Also join my Discord server and sign up for a free account on houseofcode.xyz. Both of those links will be in the description. Your support matters a lot to me, and it helps me push out more videos like this one. Thank you guys so much for watching, and good luck out there converting binary and decimal values. Bye-bye, everyone.